Welcome to our lecture on the kinetic particle model of matter. Today, we'll embark on a journey through the microscopic world of particles to understand the different states of matter, how particles are arranged and move in these states, and what happens during a change of state. Let's dive into the fascinating world of matter. What is the kinetic particle model? At the heart of understanding matter's behavior is the kinetic particle model. This model explains that all matter is made up of tiny particles that are constantly in motion. The temperature of the substance affects the energy and, thus, the movement of these particles. This motion and the forces between particles are what determine the state of matter. Matter exists in three primary states: solids, liquids, and gases. Each state has distinct characteristics due to the arrangement and movement of its particles. Let's explore these states one by one. In solids, particles are tightly packed together in a fixed arrangement. This close packing results in a definite shape and volume. The particles vibrate in place but don't move from their positions, which is why solids are rigid and incompressible. Liquids have a definite volume but take the shape of their container. The particles are close together but not in a fixed position, allowing them to slide past one another. This fluidity is why liquids can flow and take the shape of their containers. Gases have neither a definite shape nor volume. The particles are much further apart than in solids and liquids and move freely at high speeds. This freedom of movement allows gases to fill any container they're in, expanding to fill the available space. Matter can change from one state to another through physical processes like melting, freezing, condensation, and vaporization. These changes occur when energy is absorbed or released, affecting particle movement and forces. Melting occurs when a solid absorbs heat, increasing particle movement until the forces between them are overcome and the solid becomes a liquid. Freezing is the opposite process, where a liquid loses heat, particles slow down, and the substance becomes a solid. Boiling happens when a liquid absorbs enough heat for particles to overcome intermolecular forces, becoming a gas. Condensation occurs when a gas loses heat, particles slow down, and the gas changes into a liquid. Sublimation and deposition are fascinating changes of state. Sublimation occurs when a solid turns directly into a gas without becoming a liquid first, like dry ice. Deposition is the reverse, where a gas turns directly into a solid, like frost forming on a window. Understanding the kinetic particle model helps us explain everyday phenomena, from why ice melts in your hand to how water turns into steam. It's a key concept in physics that has real-world applications in industries, medicine, and environmental science.
Here you can see it's a simulation related to the states of matter. Let's open this. First of all, let's open the states. Here you can see these are the molecules. First of all, I consider the solid. You know that the molecules of the solid are very closer to each other. There is a very small spacing between these molecules. After that, let's look at the molecules of the liquid. You can see the spacing between the liquid is very large as compared to the solid. And at the end there is a gas. The particles of the gas are very far apart from each other and these are easily moving. So let's go back to the solid. If I suppose that I want to change the solid into liquid, then what will happen? I have to increase the temperature here. So first of all, if I supply here the heat, which is in the form of temperature, you can see there is a thermometer which is showing the reading of the temperature. It is increasing. Now the distance between the particles is larger as compared to the solid. It means that's the liquid state. And at the end, when the distance between these particles is very large, that they start moving randomly. It becomes as gas because the gas molecules have no fixed shape and volume, and these are randomly moving in all directions. So I can simply say that when you increase the temperature, the solid can be changed into the liquid and the liquid can be changed into the gas. So let's go to the phase change. What happens here? First of all, you have to increase the temperature here. Then what will happen? The spacing between the particles increase and the solid changes into the liquid initially. By further heating the system, the liquid changes into the gas when the particles start randomly moving. You can also see here the effect of the temperature. Let's bringing it below. Now you can see the collisions increases when the pressure increase. Here the pressure going to increase. By increasing the pressure, the collisions per second between the molecules of the gas increases and they collide with the walls of this container very rapidly, change their direction. So there would be the change in momentum due to which the particles exert a force here and there would be the pressure. So I can simply say that by increasing the pressure, the particles collide with each other very rapidly. You can also see the temperature is also increased because here by increasing the temperature, the speed of the particles increase, and by increasing the speed of the particles, of course, the average kinetic energy increase. So if I bring this back, then what will happen? The pressure is decreasing. You can see the speed is going to decrease and the collisions also decreasing. So in this way you can see the effect of the temperature and pressure on the molecules of the gas.
Let's look at an exam question states. At minus 39 degrees Celsius, liquid mercury solidifies without a change of temperature. Which row shows whether the mercury absorbs or releases energy and what happens to the bonds between the mercury atoms? For the transition from a liquid to a solid, like liquid mercury solidifying at minus 39 degrees Celsius, the correct understanding of energy and bond strength changes. When a substance solidifies, it goes from a state of higher energy, liquid, to a state of lower energy, solid. This means that energy is released during the process. As for the bonds between atoms, when a liquid becomes a solid, the particles move closer together and arrange themselves in a more orderly structure. This means the intermolecular forces, or bonds, between the atoms become stronger as the substance solidifies. Based on this explanation, the correct option is row C, energy is released and bonds between mercury atoms become stronger. Another exam question states that equal volumes of solids and liquids experience different changes of volume when they are heated through the same temperature range. What is the reason for this? A. The average increase in separation of the particles in a liquid is greater than the average increase in separation of those in a solid. B. The average increase in separation of the particles in a liquid is less than the average increase in separation of those in a solid. C. The particles in liquids expand by less than those in solids. D. The particles in liquids expand by more than those in solids. The correct option is A. The average increase in separation of the particles in a liquid is greater than the average increase in separation of those in a solid. This happens because the particles in a liquid are already more spaced apart than those in a solid and have more freedom to move. When both solids and liquids are heated, the particles gain energy and move more, leading to an increase in their separation. However, due to the less rigid structure of liquids compared to solids, the particles in liquids can move apart more significantly. This greater mobility allows liquids to expand more than solids when both are subjected to the same increase in temperature. Essentially, the difference in expansion rates is due to the inherent differences in the structural organization and flexibility of particles in solids versus liquids. Let's explore another exam question states that which row describes the forces between the molecules and the motion of the molecules in a solid? Try to figure correct option. As we know, in a solid, the molecules are closely packed together in a fixed, orderly arrangement. The forces between these molecules are very strong, which keeps them in place. However, the molecules are not completely static, they vibrate in place. These vibrations increase as the temperature increases, but the molecules do not move freely past one another as they would in a liquid or gas state. The correct row that describes the forces between the molecules and the motion of the molecules in a solid is row B. Forces between molecules, strong. Motion of molecules, vibrate only. Let's explore another exam question states that. Which row describes the forces between the molecules and the motion of the molecules in a solid? Try to figure correct option. As we know, in a solid, the molecules are closely packed together in a fixed, orderly arrangement. The forces between these molecules are very strong, which keeps them in place. However, the molecules are not completely static, they vibrate in place. These vibrations increase as the temperature increases, but the molecules do not move freely past one another as they would in a liquid or gas state. The correct row that describes the forces between the molecules and the motion of the molecules in a solid is row B. Forces between molecules, strong. Motion of molecules, vibrate only. Look at an exam question about gas. The table gives information about molecules. Which row describes a gas? Try to figure correct answer. In the gaseous state, molecules are widely separated from each other compared to solids and liquids, and the intermolecular forces are minimal or negligible. This allows gas molecules to move freely and occupy the entire volume of their container. So, the correct row that describes a gas is row C. Force between molecules, negligible. Distance between molecules, far apart.